Okay, let's do this. You guys know when two segments are congruent, they have the same length. You know when two angles are congruent, they have the same measure. Well, today what we're going to talk about is when are two polygons congruent. And what I refer to as a polygon is a multi-sided figure. So triangle, quadrilateral, pentagon, octagon, dodecagon, decagon, multi-sided figure. We're going to really focus on triangles because that's the focus for this unit. But before I do that, what I did is I put two quadrilaterals up there, A, B, C, D, and W, X, Y, Z. And I told you, look what I gave you, that those two quadrilaterals are congruent. And if they're congruent, ready, here's the big piece for today. If they are congruent, their corresponding parts are congruent. So if you give me a side in quadrilateral ABCD and tell me what side it matches up with in WXYZ, those two sides are congruent. You could also do it for the angles. So if you tell me what angle D matches up with here in WXYZ, those angles are congruent because the quadrilaterals are congruent. So this is what I'm going to do. I'm going to go around the room now, and I want you to give me a pair of sides that must be congruent. And not any two sides. I want corresponding sides. So if I took this ABCD, slapped it right on top of WXYZ, what sides would match up? Because those are the sides that are going to be congruent. All right, so let's start this off with, just think I can get a number right away. One, think I can get a number? Of course not. I'll be a part of this today. Here we go, 5. Give me a pair of sides that match up, 5. CB and XW. CB, segment CB, congruent to segment XW. They do correspond, and because the polygons are congruent, that means they're congruent. All right, another pair of sides that are corresponding and meaning they're congruent. Here we go, 8.
Line segment DA is congruent to line segment YZ.
There you go. 2 more that are congruent to each other. 2 more. Let's do it. 16.
Yeah.
Oh boy.
Segment DC is congruent to segment X1.
Hey, there you go. Nice job. Under 15 seconds as well. Perfect. And 1 more pair, please. 1 more pair. 6. AB and WZ. Perfect. Okay, can you give me the angles that are congruent now? Again, the quadrilaterals are congruent, which means the corresponding angles are congruent. So give me a pair of angles. You can only use a single letter for this. 12.
Angle C is congruent to angle X.
Yep, C congruent to X. That is true. More. Here we go, 11. Okay.
Angle B is congruent to angle W.
Okay. Another one. 12.
Angle Z is congruent to angle A.
Yep. And the remaining pair will be 16. It's process of elimination here.
Okay, angle D is congruent to angle.
Thank you. Okay, I have a big secret to give away right now. As all of you were telling me these sides and angles, I never looked at the diagram to see if you were correct or not. But I still knew you were. Okay? When somebody told me C was congruent to X, I didn't even look here, but I knew it was correct. Here's how I knew. Look at the given statement. Do you see where C is in ABCD? It's the same position X is in ZWXY. Do you see that? Look at here. Line segment CB. It's in the second and the third spot. XW, second and the third spot. That's how this is called a congruent statement. And when congruent statements are written for you, they are written in order so the corresponding sides and angles match up. Do we see that? Do you see what I'm talking about there? Okay? Because you're going to create your own today too before you leave. And when you create your own congruent statement, you can't just put it in any letter order you want. You have to make sure the sides and the angles match up in your statement. So I didn't even need the diagram to look at. I just looked at the statement. Okay? All good? All right. So when the heck are two polygons congruent? All right? And this is going to be theorem number 1. How did I know quadrilateral ABCD was congruent to WXYZ? Here's how I knew. If two polygons are congruent, all corresponding sides and angles are congruent. That's when two polygons are congruent. If all their sides are congruent and all their angles are congruent. If one's missing, no good. And we're going to refer to this as a shorthand definition of congruent polygons. Okay. I don't know, did you guys leave a little room there? Because I'm going to put a second one in a minute there. We're going to go back and do a second one. Second theorem. All right, let's do this. Let's get to these triangles. Now this is where the fun begins. Unit 1, 2, and 3 coming all back now. I have a diagram up there of two triangles, ABC and ECD. I gave you some information in the statements. I want to know, are those two triangles congruent? So let's just mark the diagram right now. I don't want to do the proof yet. Let's just mark the diagram with what we know. We know B and D are right angles. I know AB and ED are congruent. BC, and get some doubles here, congruent to CD. And oh, let's go some triples. AC congruent to CE. Okay. Are those two triangles congruent? Well, let's go back up. When are two figures congruent? If all the corresponding sides and angles are congruent. Do we have that in these two triangles? Let's talk. Do we have all the corresponding sides congruent? Yes. Now let's go to the angles. Are all corresponding angles congruent? Well, let's take a look. What do you know about angle B and angle D? They're right angles, so I know they are congruent. I didn't give it to you, but can you tell me any other pair of angles up here that are congruent based on this diagram and how it looks? Go ahead, Mike. These two are congruent to somebody else because they are vertical. Remember, vertical angles are congruent from unit 1 or unit 2. Now, the only pair I don't have congruent are what? E and A. Darn. So you're telling me these triangles are not congruent then because I don't have that pair. Not yet, kids. Not yet. Watch and learn here. I will help you get A and E congruent. Here's why. These are two what? Well, no, I'm sorry. These figures here. Two triangles. How many degrees? 180. Watch, ready? And I don't need you to write this down. Here you go. If I have two triangles, let's say that angle's 20, not drawn to scale, this angle's 100. You have two pairs of congruent angles, right? Two pairs of congruent angles. What do you know about the third pair? Shouldn't the third pair be congruent as well if they have to add to 180? Does everyone see that? If two pairs of angles are congruent in a triangle, my verticals and my rights, the third pair must be congruent. Okay? That's theorem number 2 if you just go back real quickly. In two triangles, if two pairs of angles are congruent, the third pair must be congruent. And the name of this theorem, very, very clever. Very clever. This is called the third angles theorem. So are these two triangles congruent? Are all the corresponding sides and angles congruent? Yep. Now I just want to write it properly in a proof. Okay, the saying that the two triangles are congruent. So what you guys need to list out, before you tell me these two triangles are congruent, I need to see in your proof all three pairs of sides congruent, all three pairs of angles congruent. Well, what did I give you already? All three sides. You just got to work on the angles now, because we have not written down a single pair of angles being congruent. But we know why, because we talked about it. We just got to write it down. So what do we know about angle B and angle D? They're congruent because of the theorem that used to be up on the board. All right angles are congruent. Give me another pair that we already said was congruent. Go ahead, Lauren. Well, not yet. I'm glad you did that. I can't write A congruent to E yet because I don't know if two pairs are congruent yet. So I need that second pair, which would be, redeem yourself. You got the right angles congruent. I can't say angle A is congruent to angle E yet unless you get that second pair of angles, which are angle BC. Angle, the vertical angles. Yes? Where are the vertical angles? Are we looking on the same? E, not EDC, ECD. Whew. Do you feel my pain now, Zach? Okay. Is everybody all right? Okay. Vertical angles are congruent. And in all seriousness, please do not call that angle C congruent to angle C. It's not. Okay, I see that. Do see that a lot at the beginning of the year. Oh, angle C congruent to angle C. No. We name it with 3 letters there. All right, and now the third pair of angles, yes, we're A congruent to E because of the third angles theorem. And I don't know if you missed that when I was talking to Lauren earlier. That has to be listed last, because third angles theorem says you need 2 pairs of congruent angles first, which I now have. Oh, whoa! We still have to say what about the triangles? That they are congruent, and this is what I went back to on the first page. Corresponding sides and angles have to match up. I am going to be picky about that, especially in an honors course here. Name this triangle any way you want. BCA. But you cannot name the other triangle, the second triangle, any way you want. The sides and angles have to match up appropriately. So you're thinking to yourself, okay, angle B was congruent to angle D, C, and A was congruent to E. Let's see, do the sides match up? BC, DC, yep, we're good. And this is because of definition of congruent polygons, or you can write out the whole definition if you'd like, whatever floats your boat. So do you guys see all the information you need for 2 triangles to be congruent? Basically 6 facts, all 3 sides and all 3 angles. All right, one doesn't make you great. Let's keep it rolling. I'll give you guys some time to set this one up right now. Okay, here we go. Let's start with the sides. How many pairs of congruent sides do you have? 2, which means we need to find the other pair. What do you notice about that other pair? What's the missing side in this triangle? G, N. What's the missing side in this triangle? Oh, so you're saying we need GN congruent to, is that a true statement? based on the very first property you ever learned, which was called reflexive. That's where you're going to start using it again. And just to show you my notation, anytime a side is reflexive, I usually don't put a hash mark there. This is just how I roll. I put an X there, but however you want to do it. But if you see me do it, that's denoting it's a reflexive side. You want to put a happy face, a heart, a check mark, whatever floats your boat. Go ahead. Okay, all the angles are done. Sorry, all the sides are done. Let's go to the angles now. I gave you one pair of angles. You guys are on the hook for the other two now. Where are the other two pair of angles going to come from here? Here we go. Number 9. Where are the other two pair, or one pair at least? Oh, easy. Okay. Anybody else hear that? It's like number 9. Absent! Get off our case. Who's got 8? Karma. All right, moving on.
Angle G and C is congruent.
Ooh. I'll write G and C.
And angle G and D are right angles.
Good. You got to tell me the right angles first. Because perpendicular lines form right angles. Now you can tell me they're congruent. All right angles are congruent. You guys are on a roll. And then how do you get the third pair of angles congruent up there? How do we get the third pair congruent? Who's got 10? Hi.
Isn't it angle G congruent to angle? Oh wait, angle CGN congruent to DGN.
You got both pairs of angles already congruent in two triangles. So why must the third pair be congruent then?
Oh,
Third.
third angles.
There we go. Third angles theorem. And now the triangles are congruent. Guys, you don't need to make up your own statement. It's already up there in the proof. Oh, jeez. I even forgot about that. And then, yes, definition of congruent polygons. How you feeling about these proofs? All right? Everyone all right? Not too bad. I think they're a lot better than the parallel perpendicular line ones, but just my feeling. Okay, let's crunch some numbers now with congruent polygons. All right, example 3. I have a different, you guys have a different one, RVS. Okay, these two triangles are congruent. So you know all their corresponding parts are congruent. Find X and Y. What do you guys want to start with? I don't care. Class decision, X or Y? Okay. I guess I'll go with X. X is at angle T. So what I need to know is, what does T correspond with in the other triangle, RSV? And if it's hard to tell from here, you can also go to the congruent statement. T is in the first spot, and so is what in the other triangle? So is what in the other triangle? So is what in the other triangle? What are you, pirates? Fell for it again. All right. Someday you'll learn. Angle T congruent to angle R. Yes. It's all right. Don't worry. 5th period fell for it. 1st period didn't, though. They were pretty quiet. But I don't know if they know how to talk or not. Okay, so it's congruent to angle R, but I don't know what angle R is. Can you find it? How? How do you find angle R? $16. How do you find angle R? It's not the third angles theorem at all.
Why not?
Third angles theorem says a pair of angles are congruent if the other two pair are.
We're finding angle R.
Yeah,
Yeah.
it's not the third angles theorem.
Oh right. Well, you have 180 in the triangle.
Yeah,
And you subtract 90 and 70.
I believe that's the triangle angle sum theorem, but
Is it?
yeah, I believe so. Third angles theorem, Zach says, if I had two pair congruent, I don't have two pair congruent over. Yeah, I know. Yep. Okay, that was fun like usual. So that'll be 12 degrees, which means angle T will be 12 degrees, and so will X. Whew. Okay, finding Y. Y is on segment RS, so please tell me what segment RS corresponds to in the other triangle. 10? ST. So RS is congruent to ST. Okay, ST is labeled as 24.5, right? So 2Y minus 1 RS equals ST 24.5. And this is not going to be done for free. We'll wait on you, number 2.
12.75.
Nice, right away. 12.75. Any issues before we end this with writing your own congruent statement? Oh, did I do something wrong?
I think so. Like, wouldn't like RS be like equal to VT? Because they're flipped.
What do you mean?
Like you said, RS.
Yeah, RS, TS.
It doesn't look right.
What, RS? And then RS here is a leg. Right? I'm assuming this is the other right angle. Oh, I guess. Okay, I guess, but I just went by the congruent statement, so. I see what you're, so you turn it around and it should be on VT. Okay, that's not what the congruent statement said. I'm just going by the congruent statement, so it's written in that order, so I'm going with it. All right, valid point, but I got to go with the congruent statement, so. Okay, this last one, writing your own congruent statement. Are those, first of all, are those triangles congruent? I have a little issue. Maybe you can solve it for me. I know if two triangles are congruent, all their corresponding sides, which I have, are congruent, and all their corresponding angles are congruent, but they never put any arc marks on H and R. Did they need to? Why not? What tells me H and R are already congruent? Third angles theorem. So go ahead. Let's write our own congruent statement. It does not matter how you label your first triangle, but it will matter how you label your second triangle. Whenever you're ready there. 10. How'd you name the first one? DFH. Fine. By the way, there could be 6, 7 different answers here, all correct. DFH, then you're going to give me? Oh, what's D congruent to?
So Z.
There you go. Okay, not the only way. It all depended on how you wrote this first one. Okay. Do you guys have any questions here? All right, hold on before we get to the homework.